Bonjour, bonsoir, bienvenue dans le Cloud Cleaner, le podcast qui navigue parmi les nuages. Je suis Anthony Monté, le fondateur de Cloud Mercato, un cabinet de recherche et conseil spécialisé dans l'analyse du marché du cloud. Et je suis comme d'habitude avec mon compare de toujours, monsieur Jérôme Blin. Bonjour Jérôme.
Bonjour and guten Tag.
Et je suis également avec Daniel. Guten Tag Daniel.
Bonjour, salut.
Alors, avis aux francophones, Daniel est germanophone. Ce podcast sera donc en allemand. Donc, Hans zwei drei, c'est une blague, ça sera jamais en allemand. Désolé. Es ist ein Witz. Et je pense que c'est ça. It's a joke en anglais. Et donc, of course, on va continuer. We're gonna continue in English. So, let me give you a small introduction for this podcast. A small introduction with a context. So, do you know Cloud Mercato? We are, yeah, I just said it, we are Anthony Monte, etc. But really like what we do in our daily job. So there is the dedication about the study of the cloud market, the tons of data that we have about pricing, location, performance, and more and more. But have you ever wondered how we collect all the data that we have? For this, I personally developed a platform that automatically collect data across all the cloud API about AWS, about Google, Oracle, but also about Leaf Cloud or Open Telecom Cloud or Scaleway. And this platform helps me to do various kind of things like collect the data from the catalogs. So it's more or less easy. I scrap the APIs and get it in my database. Collect the pricing, it's more complicated because the billing options are not the same with all the cloud provider. When you hear monthly on this cloud provider, it won't be the same monthly on the other one, the same for the 1 year, 2 years, 7 years for some cloud providers. And also it helps me to collect the performance data. And maybe it's 80% of my job. The pricing and the catalogs, when you write it on Python, it's done and you just launch it each Monday, each Wednesday, etc. But the performance data, you get to think more about things. There is an engineering about how and what do you want to collect about the performance. And also it could be about anything, flavors, bar metals, function, object, block storage, database, and it could be about any workload, video decoding, encoding, scientific computing. It could be about networking, about database again. And so when Cloud Mercato delivers a result about a flavor X doing a thing Y, there were the following steps. Firstly, we define a workload. Next, we boot our requirement. It could be the function, it could be the VM, it could be the network, it could be the network links, the IP or whatever. We have to set up the configuration, so install the software. We get to think about how the kernel is configured for the VMs, what is given by in terms of storage for the software, etc., etc. And after we run the evaluation, at least we do that 3 times for one data point because we would like to be sure and not give a number that is lying in the cloud. So fortunately, to do all that, we have the Spoken platform that saved my time, really. It's a reality. It saved my day, my time, and I wouldn't say more about my own code, but yeah, I like it. And but still stayed engineering required to establish a relevant test, a thing that when people will read it, say, oh yeah, it's really relevant, I like it, and I can share it. And Cloud Mercato, we are not really, I would say we are quite good at the evaluation of machine across dozens of types of workload. As a former sysadmin, I know how to configure a machine, how to play with a function. I understand the network. And the PaaS, like the FAS, like the SaaS, are generally tasks with measurable things. So when I see a high-level cloud service, I can often compare that with a low level that I did in the 90s or other of our history. But there is still a complex domain for me, a thing that is deep, a thing that is versatile, the database domain, where you can find columnar database, you can find NoSQL database, real time, etc., etc. Plenty of things. At the end, it's a topic in a topic. So uh, I, I'm in the business since a long time, so I can install my MySQL, I can install my PostgreSQL, I can understand what I do, I can tweak a bit it, I can say, okay, MariaDB versus MySQL. I can do that. But when you look at the cloud catalog, it's huge. You can have the MongoDB, you can have the Elasticsearch, you can have today the DuckDB, the Firebase, etc. And I don't mention the proprietary database made by the cloud provider themselves, like Azure, Google, or AWS with Aura. So plenty of things for plenty of usage, plenty of workloads. And because for a lot of things too, but for the domain, I think I definitively don't have the end question of plenty of things. So I invite you someone that can have more than me to offer, and it's Daniel Seybold from Benchant. So Daniel, could you introduce yourself, please?
Yeah, thanks for the first of all, thanks for the invite to today's episode. So happy to share some insights on the database when it comes on the database level when it comes to performance questions and performance assessments. So I'm Daniel. I'm one of the co-founders of the company Benchant. We are a startup, or more precisely, a spin-off of the Ulm University. So me and another co-founder, we have a background in academia. Worked, well, for me, 7 years, my colleague over 10 years in research in distributed systems. First distributed systems, then cloud systems. Then also I brought in the focus on database system because that was the time when, well, started the research, was also the time roughly where the NoSQL databases, well, they were already there since a few years, but it was the time when MongoDB got more popular in the industry, where a lot more NoSQL databases popped up on the market. And well, basically since beginning of 2010, the whole database market is still growing, expanding. As you said, Anthony, so nowadays there's so many options out there when you look for the right database for your data intensive application. So it's not as easy as it was before when you just pick IBM or Google, IBM or Oracle as an appliance, and you just buy it, and that gonna serve your needs for, well, a lot of money, of course. So nowadays you have plenty of options to use open source databases, managed databases offered as a database as service offer, from, well, open source Postgres, MySQL, up to some proprietary database systems. And well, we are working in a very similar field as you already pointed out. We're also looking into the performance assessment, price performance comparisons when it comes to this whole database landscape. So there are already standard benchmarks out there, but there are also new kind of workloads evolving. Well, the very bleeding edge are, of course, the vector workload or vector database systems for the whole generative AI that frame a complete new picture on the demands for the database systems. But it's not only to just run the workload against the database system. It's also that you need to know how to configure the database in terms of cluster size, instance size, replication settings that are, well, of course, there are some common approaches, but then there are also very specific approaches to certain technologies or just certain databases. And in order to provide that data to the customers, we have a very similar approach as you did. We also built a framework that is able to run automatically large-scale benchmarking studies for measuring all these knobs and bolts and the impact on the performance and price performance that you will get out of that. So that's what we basically do with Benchant.
Thank you very much. Thank you very much. And so your personal background, you said you come from the University of
Ulm. So
Ulm.
Ulm, southern Germany.
Where is it?
Southern Germany, right between Stuttgart and Munich. So
In the Baden-Württemberg.
Yeah, exactly. Yeah.
And so you came from an approach from the university. And so what is your background? What kind of diplomas did you get in university?
So interesting thing is that before I did my PhD, I did my master thesis where the topic was to design and implement a highly scalable database as a service offer. Well, that was probably a bit ambitious at that time, but it was definitely an interesting aspect. There, I started to look into the performance of distributed database systems. I think back in that time, MongoDB, of course, Cassandra, Couchbase, but also my distributed MySQL cluster, and if they're operated in the cloud, and which one provides best performance, which one would be suitable for a database as a service offer. So that was basically the scope. And then it turned out that this is all of that is way more complex than initially assumed based on the topic. That's why I decided to pursue that research in a PhD position at the university in Ulm, where I was continuously working on the performance assessment of distributed database systems, but with the focus on identifying the impact on, as you already pointed out, on the infrastructure layer. So what is the impact of different kind of storage backends? What is the impact of different kind of virtualization layers in between on the performance that you will get, also the network layer, and how you need to measure the performance of distributed systems to ensure transparency and also reproducibility of the measurements. Because everyone can more or less run a benchmark against the distributed system, but if the results are meaningful in the end, if they can be adopted by someone else, that's different kind of a story.
Yep, exactly. We are in the cloud screener, so we of course talk about cloud. And my personal feeling is that in the 90s and in the 2000s, we had database, we had more or less VMs with VMware Cloud in private cloud, but we installed all the database that we had directly on the bare metal generally, and so we get the performance of bare metal in the end of yes, I would say in the early 2010, maybe we can reach 1 billion IOPS, so we can go very fast. And when people migrate to the cloud, they do not measure things basically. And if you measure the general and the average block storage that you can find on the market, you won't go up to you will go up, excuse me, to maybe 30, 40K IOPS. So we lose in something like 800,000 IOPS without noticing it and paying more for a lesser result. Do you have the same observation that at the end, VMs, if you don't pay a lot, the VMs won't give you the same performance at the same price that you can have with I don't know, a simple server that you can have at office?
Definitely. So, that's nature of the. If you put up another abstraction layer on another layer and another layer, that's gonna cost you performance. So that is for sure. Of course, you will get other benefits. So for instance, easier maintainability, easier operability, thinking of the whole Kubernetes, automated deployments and stuff like that. But yeah, as you said, it's definitely the case if you have if you want to have the bare performance, then you should go for a bare metal instance. But there are the downsides, of course.
Clearly.
We also did a research paper back in academia where we measured the impact on a database system. I think it was MongoDB. If you run it on bare metal versus if you run it in a container on bare metal versus if you run it on a VM versus if you run it in a container on top of a VM. And that also clearly showed how the performance decreases with the layers that you add on top.
Yep. Yeah, I think I read it, and the best benefit if you really would like to create a box on your bare metal will be the container directly on bare metal, if I remember well.
Yeah, exactly. Yeah, and then of course you can play with the kind of storage drivers that you use, for instance, with Docker to plug in the storage into your container to even tweak it more. But in general, yeah, that would be the option to go
Yep.
for the best performance.
Yeah, but the way I was talking about it was a bit the first thing that you can think about how it was better before. But at the end, if you put your data on a block storage, you have an automatic 3-time replication at least. You can backup, snapshot, move forward, copy your data easily, create a block, another block, put that on another VM, etc., etc. So clearly, the benefit of cloud is here. But to be in the middle of what I said previously and what I'm saying now, um, the block storage performance is clearly defined by the cloud provider. If a cloud provider gives you a very good performance on your block storage, two choice. Firstly, you paid an expensive block storage. It's understandable if you have expensive things to do. Second things, they do not cap the amount of megabytes you can send on their link. So the one you pay and you are sure to have what you want. The second one, maybe you are sharing an environment, and for a database, it's maybe not the best thing to share the environment. So again, you can just look at things from far, far, far away and think it will match with your requirement. You get too deep to go deep and understand what you do. But about what to do, what the cloud has to propose, I got a question for my personal curiosity. In, Nowadays, is it still relevant to say MySQL is not columnar? If I have to store a lot of things with a columnar database, I should choose I don't know what is the thing that we are using now for that, but I should use another DB. I got the feeling that everything is everything nowadays. Maybe on Postgres, everything is everything. You can install a real-time database, you can install a vector, you can install everything. So I don't really understand where I should go when I get my simple workload. I don't know which database to use, except
Mhm.
Google and ChatGPT can give me some answer, but
I,
maybe you are
I,
better
I
than me.
wou- yeah, I wouldn't recommend to go for that. You will get an answer, but in that case, probably not the optimal one. But yeah, that's a very interesting question that we also work a lot with our customers, because in the end, the answer is, as it is quite often in that area, it depends. Because if you have, let's say, an analytical workload that you also need to handle besides your OLTP workload, for instance, and you have your MySQL database, well, you can do that to a certain until a certain level is reached. So if your data set reaches, let's say, 500 gigabyte or terabyte or whatever, depending on your instance size of the MySQL, then it's at least worth considering other options that are specialized on handling these analytical workloads. If it's just a small data set and you run it in parallel to your OLTP, and also they're not that frequent data access, then you can do it with your old school MySQL, so that's not a problem. The same question is right now very often asked when it comes to vector database, because all database, let's say, established and modern databases provide an extension for vector search. And they're the vector native databases, of course. And then question is always, when does it make sense to switch to a real vector native database instead of just using extension? And this is also the case for other kind of workloads. Time series, similar thing. They're dedicated time series databases, but you can also handle your time series workload with your MySQL database if it does not reach a certain threshold of data that is ingested and queried in parallel. So there it's always the it depends question. And as you said, for Postgres, the ecosystem is that huge that you can basically install an extension for Postgres to do or to handle any kind of workload that you can think of. Vector, analytical, time series, several kind, NoSQL workloads, whatever. So
Yep. Yeah. JSON or whatever. But yeah, at the end, it's a matter of check the numbers before, during, and not after because it's too late.
exactly.
Jerome, do you have any questions?
As ever.
Yes. Go ahead.
Wait a second.
Go ahead.
I'm a little bit sick. Sorry. Yes, question. Question about something we talked about since yesterday with Anthony, about a quote from Peter Drucker. For the French, it's not Michel Drucker, as I say. To be sure, it's Peter Drucker. It's a host, a TV host for the one that doesn't know. And Peter Drucker, it's a guy that work in management, creating companies, etc., etc. It's a kind of influencer, but an influencer that wrote books. So the quote of Peter Drucker, I loved and I read in a book in 2017. It's with my approximative English. Everything that can be measured, mesuré in French. Everything that can be measured can be optimized, can be enhanced. First, I know a little bit your answer about this, but do you believe this? And second, do you believe that people are really aware about this, especially your leads, the people your clients, even your actual clients or your future clients, are really people aware that the data is a real process to a better world? Actually, the analysis and the benchmarking about this.
Really good question. So we also hear that, well, everything that you can measure, you can tweak it, temper it, whatever. So that's probably something that everyone is has to face who does benchmarks. So same, I assume the same for you a lot. And well, that's also something that we addressed already back in research, as the only option is to have the whole process reproducible and also to expose and also in a structured way all knobs and bolts that were applied for this one configuration. Because nowadays, if you do performance measurements, especially in the cloud context, there are so many knobs and bolts that you can play with, and there are so many layers in between that you can't actually, tweak it or influence it, but they're gonna be impact. So if we think about the daytime when you run measurements, so if you benchmark something in the AWS Frankfurt region. If you do it for provider A at nighttime with low traffic, for instance, and for the other provider in daytime, the peak layer on some shared instances, you will get different results. So that's maybe something that you also can comment more. So I think you did also a lot of looking into that. We saw that for some database systems where we did that in research. And yeah, so our approach is that we share all the data to have that reproducible as well with the customers if they want to see why the data is what it is. Of course, on the cloud layer, you can't just do that to a certain level. That's different if you do that on-prem or on bare metal resources. And yeah, when it comes to if our customers are aware of that, so we are still in the process to create the awareness that such data can be provided, and especially that such data can be provided on a very either very in-depth level, but also on a very recent set or on a very recent level, because many of our customers are still or know the TPC benchmarking world in the database context. So back then, where you had these Excel sheets with the where you got the performance measurements for IBM DB2 on some IBM hardware, and then you got the Oracle, and then you got maybe another one on 3 different hardware types. So that's it. What was available back then? Maybe a bit oversimplifying that, but nowadays you would have millions of combinations that can be considered. And here we're still working on getting the awareness that this is possible, and also how to fit in that data in the decision process when you build a new application that is also, let's say, data intensive application, and also as you said, Anthony, how to fit in that data in the early steps of the process and not in the end when it's too late. Because if you have to rethink your database decision because everything crashes or slows down, then it's already too late. You should do in the beginning, especially for greenfield projects.
Okay, so I have a question I can also ask to Anthony, but I ask to you and the full world of benchmarkers that are not so big, that is not so big. But what is the biggest difficulties for people that work in benchmark and in benchmark of database, especially?
Well, I would still say to ensure the fairness of the results, because
I want you to say that. Go ahead.
to ensure the fairness and transparency of the results, because even if you expose all the data and the knobs and bolts that you applied, and you might run the same benchmarks, let's say 3 months later, there might be some changes on the data on the cloud provider side that it's just not exposed, and then results differ, and then you need to do way more in-depth analysis and more measurements to narrow it down what has changed and how especially how close can you analyze it. So if you can narrow it down to a certain change, or if it's just not possible. So I would say that's still the biggest challenge, but also the most important aspect, because you have to keep the fairness if you do neutral benchmarking. So which we do, of course. So otherwise, it's meaningless.
It's hard to be neutral.
Well, depends with whom you work with. Well, we have customers, so we have the end customers, so enterprises that approach us for getting a neutral view and measurements on different kind of technologies. So then it's easier. it's harder if we work with cloud and database vendors, because they also approach us to get comparisons for their market department, or also to get internal knowledge how they compete with their competitors. And then it's often more a fight to explain why this setting has to be applied to that competitor to have a fair comparison, even if it means that the actual customer doesn't get the best results. Or
There is something I wonder since yesterday. I asked. I am in an introspective period of my life. That's why I have a lot of questions. Too. You are a pure product of university, let's say like this, even if you are obviously not just this. You're a co-founder, associate, I don't know how to say exactly, also, if I saw well. I am the nemesis, not the nemesis, the antagonist of this. I am a pure autodidact. And I work in obviously a different area, which is marketing. But the question is accurate for both sides, in my opinion. Even if it's for marketing, it's maybe easier. Would you do the same if you didn't do all these long studies? Or would your process, the way you work, and all your methodology would change?
So you mean if we would do it again? Yeah.
If you yes.
Yeah. Well, I would say from the methodology wise, no, we would still do it the same way when it comes to the technical benchmarking. Of course, with the having the knowledge that we have now, we would have find some short path that we had to learn the hard way, where we did had to do a lot of digging and figuring out what were the problems. But in general, I think we would have end up with the same methodology. When it comes to more the business and marketing side, since that's something that we had to learn ourselves when it comes to marketing, especially how to promote ourselves to the market and so on. There, of course, we would have done many things different than we did, and also, let's say, finding the right terms in industry that map to the terms that we used in academia. That's also something that we had to learn. So it's completely different if you also, when we do write-ups and stuff like that, it's different if you write an academic paper than if you do a more industry-oriented white paper or blog post and so on. Yeah.
Okay. So I have one little last question, and maybe I will have other questions. I will ask between the two talks. And maybe I just realized now that this question maybe meets the other question about the difficulty. It meets, I don't know what to say in English exactly, but what is the most the role the more important for a benchmarker? Is it to be fair, the difficulty? So your role will be the most difficult thing, or maybe the methodology, the discipline, the regularity, how do you say, la veille. Comment dit-on, Anthony, la veille? The surveying the news, the products, etc.
Actually, a good question. I would still say that from ensuring the fairness, it's the most challenging, but also the most interesting part from a technical perspective. And with ensuring the fairness, there also goes along, of course, serving the whole market and the developments when it comes to new features, new releases on the database level, but also on the infrastructure level. because there's always the interplay with what is on the hardware level, new features, new resources, and how they're gonna be used on the database level. So yeah, I would say these two are the most challenging ones, but also the most interesting ones when it comes to be
It's a yin
benchmarking.
and yang. Okay.
Yeah, exactly.
And you, Anthony?
Me, I would say that the first quality is curiosity, because you discover things, and firstly, I don't know, if I drop you in the jungle and you absolutely don't know anything, so firstly you will discover a plant, you will eat it, you will say, oh, it's good, but you don't know the level of goodness at the end. Maybe you can find better, maybe you can find worse. Maybe you will eat another one, it will be a sugar test. Maybe the other one will kill you. And so you discover plenty of product. At the end, you discover that there is a marketplace with plenty of plants that are already here. But the thing is not to just discover the plant and know it, is to know how to cook them. And it's become more interesting. So clearly for me, the first thing is the curiosity. Clearly.
Okay.
Without doubt.
I will mix both of them.
But if I get to take the analogy of cooking, there is an old recipe. Um, I in the benchmark of database, the benchmark of database is really older than cloud. It's exists since ever. The main always ask how fast can my database go against the other one, and so there are standard, the TPC, D A B C D. There are a lot of letters after because there are a lot of standard benchmark produce. I don't remember exactly who produce these benchmarks, but there are standard benchmark made to say how fast will go this database against this workload. And so when I say a benchmark, it say to you, okay, you got to create this table for the relational database, of course. You got to create this table, this table, this table, define the foreign key, the type of fields, and also it defined the kind of request and how you get to fill the database. It's really nice to look at this. I personally remade myself all the standard like this with Python and Django, and I made my benchmark on it. It is nice, but a question for you, Daniel: is it not too old to take this kind of tool, all the TPC tests, etc.? Is it really something of nowadays? Firstly, is it something of nowadays? And next, at the end, the most important thing is how you configure the database. And so I don't really know if it's really important to say I use TCPD or TBTCD or E or F or G or H. Is it really relevant in 2024 to say that?
Yeah, good question. And also, I like really the analogy with the cooking and the curiosity, which is of course, yeah, a very very important aspect as well. And when it comes to the TPC benchmarks, well, on the one hand side, yeah, they are old, if you can call them old, in that rapidly evolving tech domain. But also the TPC benchmarks are still evolving, and well, not as fast as the database landscape over the last decade. But there are also efforts to establish new ones. And they are well known, and they are, well, let's say, at least they model some standard workload types when it comes to online transaction processing with the TPCC, or online analytical processing with the TPCH benchmark, that can be used as a baseline comparison for comparing, let's say, different kind of Postgres versions against each other, or Postgres DBaaS offers. of course, when it comes, and this is sufficient for many use cases. So they have transactions of different kind of complexity. They have the typical relational data model with the foreign keys and so on. They have the standard SQL queries that you would have. So of course, it gets different when you look for very specific features. For instance, if you look again for time series related or search related features, this won't be covered by these standard benchmarks. Then you need to fall back to some, or let's say, more modern benchmarks, or even extend an existing benchmark suites to exactly cover these application specific needs to have their to enable comparison.
And so, if tomorrow I call you and I say, "Hey, Daniel, I just invented the Tony DB," which is a superb DB. It's just a key value database, but blazing fast. And so, how do you imagine to benchmark it? Because it's a new debate, so I imagine there isn't a tool made for it. Maybe they are equivalent, but there isn't a tool made for it. How would you take it, benchmark it, and how would you avoid the pitfall that I could have put in my code? For example, if my database know that Daniel is benchmarking, I will go blazing fast.
I see. So on the one hand side, you want to get all the Redis customers that are now frightened by their closed source policy
I said
with that
I
key
didn't
value
say
store.
anything.
And that's a good point. Well, there are the old stories about the database vendor who had exactly these kind of optimizations implemented in their system, that it's gonna detect the TPC benchmark and have some optimizations for that in the old days. But yeah, the way to, first of all, to benchmark that new kind of database system would be to use one of the existing benchmarking suites for, let's say, at least one of the same data models. So if it's a key value store, there would be the Yahoo Cloud Serving benchmark, very suitable. And that would then be extended for the new specific database. So we did that a lot in the past, where new database vendors for time series, for instance, but also for NoSQL ones that are not yet supported by specific benchmark suites. So we did the integrations in the benchmark suites and then run the benchmarks. And of course, each benchmark has also a lot of knobs and bolts where you can configure different kind of fine-grained workloads, and then you would run them against the database, and there you will also see if there is some kind of tuning for one specific workload. So, well, you would see if there is, for instance, by default, the database is tuned for really read-intensive workloads, while for write-intensive workloads, it's doing not so good, or if it's more for the mixture. And yeah.
Yep. And I imagine that you have some kind of monitoring that you plug into your database to know, oh, you are filling this cache. Oh, this is empty. Oh, this is there is this task queue which has a 20 request or whatever.
Yeah, exactly. We also have a monitoring stack that we plug into each benchmark run that we do, that monitors the database on the system level, but also on the database layer. Then we collect all the monitoring data and correlate that with the performance and results that we got. And we're also measuring all the instances that actually create the workload against the database to ensure that there is no bottleneck on the, let's say, on the client side. Because for large scale experiments where you have then, thousands of threads creating the load against the database, the instance might be too small to run the actual load, or network gonna be bottleneck and so on. And also to ensure that this is not the case. Yeah.
Okay, so you just ignite my curiosity. And so can you give us more about how you would run a simple, let's say, a MongoDB benchmark? I would need to run, let's say there is the Tony Cloud, so a super new cloud provider in Portugal here. And we also have a TonyDB, like I said previously, but we have a TonyDB managed services where you can take Postgre, Redis, or Mongo. And I would like you to benchmark my MongoDB. And most of my customers say, oh, they would like to have a large MongoDB in RAM, especially in RAM, and just use the storage for have a persistent layer. How would you do with your system?
Well, of course, first we would need to get bit insights on the desired workload. Well, you said that preferably should everything be in RAM. So assuming that would be more a read-intensive workload than a write-intensive one, then we would apply these configurations to our system so that is configured that they're gonna be, well, data set of 100 gigabyte, for instance, and then you have a configurable number of clients that issue read requests that might be, well, maybe hotspot relay or more hotspot distribution or more uniform distributing go. Well, could mean that you have to load data from disk if it doesn't fit in the RAM. Depends on the instance size. But with all these constraints, we would identify a configuration or several configurations that map the workload that the customers expect. Run that against these MongoDB instance on that cloud provider, and also run it against, well, if it's a competitive benchmark, against other offers or just against that one, and then also fit in, of course, the pricing to see how which kind of instance size would provide the best price performance ratio. So to not over provision it, but also not to have it too small to get worse performance out of it. So where's the best sweet spot? Less.
Okay, and so from this configuration, I guess you got a web portal for your platform. So all the things that you explained to me, it's maybe 30 clicks on your platform. And next, you will maybe type run task to give a name to the task and enter, and it will boot some VMs. It will boot some database from the TonyDB services, and it will install the software, install the configuration that you requested. So about everything in RAM and shoot the disk only if it's required. And launch also and install the monitoring tools that you previously told, and run the benchmark. And so after, you can just sit here and look at some graph designing on your screen saying that, oh, there is a bottleneck here or here or here or here. I guess it's something similar like this, or maybe in the future, but
exactly. So that's how it works. Exactly as you explained it. So as soon as we have the configuration, the model that we then fit in or trigger our platform, then all of these steps are carried out automatically. So spinning up the virtual machines, installing the software on it, configuring the MongoDB instance, for instance, to have it with the in-memory engine. And then also orchestrate the execution of one benchmark, multiple benchmarks against it, collecting all the data, fitting all that data again in our internal monitoring system, and then we do the analysis of the results, and then re-triggering it with different kind of settings to get the full picture. Yeah, but that's basically how it works. Yeah.
For those who are wondering, I'm not waiting right now because I got a similar platform. And the difference between Benchant and Cloud Mercato at the end is that they have the engineering and they have the knowledge to understand how to configure the database. And this is clearly the difference between us and them. They understand the database, they know it, and when you are talking with them about any kind of database, they can put it in a case, put that case in another case, and understand it quickly. And this is not our case at Cloud Mercato. We can run benchmark. We have the system where we can save the configuration, reuse, install a database, and put this same configuration across all the cloud provider. It's not an issue. It's about what would I put in the configuration. And this is a deep question. And a topic that I would like to chat with you, it's about AI. It's about the future of the humanity, if I hear everyone. Basically, everyone wants to have its LLM at home right now. At home, maybe not, but at least for their enterprise. And the magic that you can use to have your own LLM with your own private data is the RAG. And basically you store the data somewhere and you make a proxy between the prompt and the LLM, and this proxy will request your database, more or less database. I really simplify the thing. Please do not throw any rock. But everyone, when you start to do some RAG, so it's the name of the system, you will take a vector database. Everyone is talking about vector database. Firstly, what is your opinion about all because in maybe 2 years we have 20 new vector database that came up.
At
So what is
least,
your
at least.
opinion? Yes, at least. So what is your opinion about that?
Well, it's very interesting in the sense of how the database market keeps up with the trends of the general tech world. It was because it was more or less the same, let's say, 4 years ago with the time series databases, 4 or 5 years ago, when the IoT was the hype, more or less. So there were so many new time series databases thrown on the database market. Existing vendors released their time series extensions. Now it's the same for AI, where over the last 2 to 3 years, many new vector databases approached the market, and in the same time, established vendors released their vector extensions. I think, as you said, we will see also over the next 1-2 years many more vector databases approaching on the market. Then there's gonna be the fight on who is gonna lead the or be the leading vector database, who will become an established vector database. All depends how the whole generative AI movement is going along, of course. If it explodes like some predict, if it's it won't go away, that's for sure. But let's say the increase in demand and also the applications or the business cases that you can do around generative AI will also be a main driver of the database market, for instance.
Sure.
Because we also see that a lot of database vendors are now looking for the use cases actually from the industry, or let's say at least the big use cases. And the industry is looking for the business cases actually, or more or less established business cases around generative AI. There's so much prototyping and ideas that could work out, but it's not yet, of
But
course.
do you think the winner of this race will be the
It's
most
cutting,
performant or
Anthony.
the most genuinely first? It will be just oh, excuse me. Do you hear me?
Can you
hear me?
repeat a little bit, please, Anthony? Because yes.
Yes, I was saying that, do you think the winners of the race will be the most performant database, or it will be just the company that make the best deal with Meta or Tesla or whoever who has many GPU?
That's a tricky question, because well, performance was always a main aspect for a database, but it's not the only aspect. And as you said, there will also be other more business relevant aspects, but also the ecosystem around the database will be also important because, for instance, if you see how Postgres, the whole Postgres community has grown over the last 5, 10 years, and the tooling around such a database is well tremendously has tremendously grown. And if you have a completely new database, you have to build it up all from scratch, all the tooling and stuff around that. And one other thing that's going to be important is how big will actually be the data set sizes that are required for the big generative AI business cases. So will they be really that big that huge Postgres instance, MongoDB instance, whatever, can't handle it and you need a dedicated vector database? Or will the established vendors be able to at least tweak their systems that far that they can handle most of the generative AI business cases? So then it's going to be tough for the vector native databases to sustain.
Yep. Knowing that a lot of people I'm chatting about AI and RAG, they are telling me that they are dropping a vector database for knowledge graph. And so here, another topic, another domain of and another market of plenty of actors that coming back and saying, I've got the fastest database on the market.
Yeah. Everyone has the fastest database, everyone.
Normal. I would say the same if tomorrow I invent a database. I wouldn't say, oh no, it's an average database. Just install it if you do average request. But it comes to another thing you was talking about the business side and the business aspect, and there is also the licensing aspect of the database, and for me, I'm taking a bit of distance about all that. I made all my career in open source. There is no problem on that, but I got some distance. And I was joking when Oracle bug MySQL. Sorry, sorry all, but this is my opinion. I just don't care about that. It's not my mom, so they can buy anything. And so the everyone was crying when Oracle book MySQL and crying more and more when MongoDB changed its license, and the same for Elasticsearch, and the same for other that many database. There are the forks that working or not, and the last one is Redis, exactly. But when I'm looking all that, and when I just flying over the license, I understand that personally, for my use case as a user, it will never change anything. I can still install my MySQL, my Postgre, my Maria, or my Mongo on my Raspberry, my Mac, or any hardware I would like to use. And I don't have to pay. And for the cloud provider, yeah, maybe on their business it changes things, but none of the cloud providers stop to sell this product. Even if the license changed, they didn't stop to sell the product. Maybe they have an alternative, but they sell the alternative and the original product. So it's make a lot of waves, but not for the consumer at the end.
Yeah, well, yes and no. Because for now, if we take the Redis example, it will have an impact for the future, because when cloud vendors are not able to provide the latest Redis version with the new changed license, because then they just can't do that without licensing Redis. At some point in time, it will then hit also the end user if they're using database as a service, because then they will just not get the latest Redis on whatever, not AWS, because they have their own Redis version, if I'm right, a long time with the Red. So if it's for, let's say, a smaller European cloud provider who's offering Redis, now they can do it. With the next major release, with the new version, with the new licensing, they can't. And we saw that where that is going to end up with MongoDB, because now we have MongoDB API compatible offers by many cloud providers such as AWS DocumentDB or Azure Cosmos DB for MongoDB, which is just the MongoDB API, but not the native MongoDB. So they worked around that. For European cloud providers who do not have the manpower to implement their own MongoDB, for instance, so they either have to buy the license, or there's also the initiative by the Postgres world again to provide a MongoDB API on top of Postgres. It's called FerretDB. So that makes, again, the market way more heterogeneous. As for Redis, for instance, there are already forks out there that will remain open source, that can be used by the cloud providers, which again makes it then interesting for us who runs benchmarks. And as you said, the curiosity, how will the performance end up with these forks and the, let's say, commercial or enterprise licensed Redis in the future? Will it remain the same? Will there be a drop in performance in one of them, either the fork or the enterprise or server side public license?
Not simple as that.
And these are all evolvements that the end customer will face in the end, maybe in 1, 2, 3 years, because then when when new features are added to the latest versions of the database, and they have to decide, should I now move to a different cloud provider, or what's the option?
The option given by the cloud provider. But what you told about, you may not have the latest version from the cloud provider. It's the same thing for the different Linux repository, which removed Redis directly from their repo. So clearly, from Ubuntu, from Debian, from not Ubuntu, but Debian for sure, you cannot have the latest version. You get to install it by yourself, and it's tedious as you mentioned for the cloud provider when you don't have it at managed services, but you can install it by yourself. It's cool to install by yourself, but no.
Of course.
Jerome, do you have any other question?
Yes.
What's his voice?
The voice of an old guy. I come from Alsace. You know Alsace? Alsace?
Yeah. I
At
know
the border of Germany.
I've been there.
Okay, cool. Colmar, the main, most famous city. I am in Brazil actually, so there is also, and I'm very interesting about Germany. In Alsace, I don't know if you know it, if you have some close relationship with the Frenchies. We love Germans. It's like there is a kind of model. It's a kind of model of how to work, how to have success, etc. Of course, it's not. It's a model. I am totally conscious that Germany has
realistic.
Voilà, Germany has its own problem. Germany, it's a country like every country, even if it's a very good country, sorry. It has a problem. The grass is not greener on the other part. I don't know how to say, but it's true that in Alsace, it's like we live like Germans because it's the model and it's a very long story. So I'm just it was very long to say just because why I am interesting about Germany. Anyway. My question is, how would you rate the interest of Germans about technology, and specifically about AI, the new wave AI for the big public, not for the technicians this last year, and in general, what is the interest? Because for us, Germans are engineers, people of technology too. Big cliche, of course, but it's true. There is a real industry, there is a real engineers, etc. from Germany. So how would you, is our view of Germans is accurate about this?
Yeah, so happy to comment on that. Well, based on my personal opinion, and also some is definitely influenced by the experience that we made now with our company, where we not only dealing with German or European customers, but also a lot from US. And there, when it comes to the cloud and database market or tech world, so to say, I would say that in Germany, people or companies are a bit reluctant to really adopt the bleeding edge technologies. They more prefer the well-established, long-lasting solutions that are out there. Also, open source technologies are, let's say, a typical German engineer would prefer Microsoft SQL Server over an open source Postgres. Yeah. In compared to the people from the US, they're very, let's say, open-minded when it comes to new technologies. Let's give it a try and see. And also open source is more, say, accepted than maybe in the German sense. Of course, that does not go for all the companies that we work with, but there are some that just, looking for the established technologies because they know what they get, even if it means that they, might not get the latest performance or best price performance, but they know what they got in the past and they're willing to use that for the future. When it comes to generative AI, of course, it's also everywhere in Germany now to apply that in small, medium companies in different, all kind of industries and so on. It's still a bit unclear on the business cases that you can make out of it, but I assume that's everywhere the case. Feel free to comment that for France or also for Brazil. In Germany, it's maybe also a bit different because the strict GDPR rules here, which is also a thing why, cloud computing in general, databases in the cloud are still no-go or a tough challenge for many companies to make that move. Completely different to the US, for instance.
You had many clients apparently. When I read the website, good amount of clients, long years of experience in cloud and database. What lesson? What did you learn from all these time clients and this gigantic amount of money?
Let's say we learned a lot, of course, and no client is the or there is actually not the one typical client that we well, it would make our life easier, but also less challenging. So, and of course, coming from research, we love the challenges. So we already figured out now some types of clients and what they're looking for. It's easier when, of course, for the types cloud providers, database vendors, for let's say our end customers, so the corporates or medium-sized enterprise and so on. When they ask us for these performance assessments, it's still always different kind of angle they're looking into. So it's not that one straightforward road that we go down. It's always some turns and crossroads, and we were more interested in that. And so we learned that we have to be very flexible with our customers in there, and that it's also a process to find out what they're specifically looking for, because it's not always that they approach us with a very specific question they have and we should solve it. It's more that they want to have some data for some decisions that they're not 100% sure yet how to fit that into the big picture.
And you personally, for example, I don't have the same experience in terms of length, but I noticed that from the beginning I was solo, independent, to now many things on the aspect of managing a client without talking about confidential information, just how to manage the client. Do you feel things that it's a kind of LinkedIn question? Do you think that your way to manage the client change it? For example, I'll give a typical example. At my beginning, when I had a new client, a new lead, I was like this. Oh, okay, I need to do everything now. I need to finish everything. Now I know that if I do this every day, I will finish at the hospital. And it's impossible in the long-term aspect of the thing. Do you have some things like this that changed in your professional life, and maybe some tips for people that want to be independent and make their own company?
So there we definitely learned a lot when it comes to what the customer is actually expecting from us, what we actually want to provide in terms of timeline and scheduling wise. It was, let's say, already helpful that in the academic career we worked a lot on European research projects with a lot of different parties involved, where we also had the whole project management and also timeline and more or less you could call them customers involved and so on. So that helped already to structure it, to also manage a bit expectations, but still we had to learn on the different types of customers depending on their internal processes, on their size of the company, how fast they want to move, how fast they can move. And also I think the most challenging part is still negotiating project, the scope, budget, and everything. This is going to take time. And then as soon as everything is signed and you start, then there's a whole different kind of dynamic, because then, of course, the customer wants the results as fast as possible, while the whole negotiation process can be rather slow. And then as soon as this is done, then you also need to be aware that now you have to actually go or schedule a lot of time for that and to make progress on that.
Patience is the key then.
Exactly. So and there you will always have these, let's say, slower phases in negotiating projects and so on, but you also have to be aware as soon as a project start date and everything is signed from the paperwork, then they're going to be the stressful, but also interesting days on technical work, actually.
Okay, cool. That's all for my questions for this part, but people will see the other question in another video. Teaser.
Thank you, Jerome. Thank you very much. Let's make 1 hour and more that we are chatting. So I will just leave you with a last question. There is a two job. Yeah, let's say like this, two jobs that I discovered. I don't discover that yesterday. It was years and years ago. It's first the SRE and next the performance engineer. And why I say I discover that because that's make maybe 10 years I'm benchmarking clouds, and the job of benchmarker doesn't exist. So I get to find what kind of profession that I should say to my mother. And there is performance engineering. There is the SRE, which is the seat reliability engineering. And when you look at both, they are tracking the performance of application, but not directly like I do, because at Cloud Mercato, I'm looking at the performance of the infrastructure. And next, after, you can do whatever you want with the infrastructure. If tomorrow Benchant close the door and you get to change your job, will you do this kind of job of SRE or performance engineer?
Yeah, so you definitely picked the two perfect matches. So for our, let's say, technical expertise that would match. Yeah, so it would be performance engineer or site reliability engineer. There is also I recently came across a job offer by AWS. They have the benchmarking expert or the benchmarker in their job portfolio, where they actually do also on the infrastructure layer, network layer, and so on, benchmarking of their services. But well, that's probably a position that is only available at companies in the size of AWS.
Yep.
Apart from that, yeah, it would be performance engineer or SRE. There are, for instance, for database companies, they have these positions also internally depending on their size. So some of them have specific performance engineering departments where they run and build continuous performance testing systems for their products. And yeah, same goes, of course, for cloud providers.
Yeah, it's interesting because you could opt for the SRE position, but from my perspective, the SRE was the former. So when the sysadmin they always did monitoring, it was the half of the job at the for sysadmin, and nowadays. Now there is a DevOps and whatever, so you get to find another job title, and a lot of them are SRE. And you don't come from this domain exactly, but you got the qualification to do that. So I wanted to notice that. But now let's make 1 hour and 25 minutes that we are discussing. And for the end of this podcast, excuse me, I would like to ask you if you have one last note, one last thing that you would like to give to our, how we say auditor in English, Jérôme?
Auditor.
Let's say
No.
auditor. To our audience.
Listeners, I don't know.
Exactly, listeners. Yeah. So, yeah, Daniel, do you have a last thing that you would like to say to our audience?
Well, I think I got a quote, I hope I got it right, by Grace Hopper, so one of the pioneers in IT, and I think that matches both of our domains. So one accurate measurement is worth more than 1,000 expert opinions. So that's
Exactly. Love this. So thank you very much, Daniel. Thank you for your time. It was a pleasure to receive you for this podcast. I hope you like it as well.
Yeah, thanks a lot for the invitation. It was a pleasure. It was fun. Thanks a lot.
Thank you. Bye, Daniel. Bye, Jerome.
Ciao, ciao todos. Portuguese. I don't know.
Bye bye.